Alright, so today is 6-5. Trapezoids and kites. Your book only talks about trapezoids. I'm going to include kites in this as well. Alright, so let's get a definition for a trapezoid. And I'll show you a picture of what a typical one looks like, or a couple of typical ones might look like. So, trapezoid. Trapezoid, if you look at your tree diagram, is it in the same family as a parallelogram? No. So we're starting a whole new branch of the family. It is a child, so to speak, of the quadrilateral, right? So it's a sibling to the parallelogram, but they're different. They have a couple of similarities depending on what kind of trapezoid it is, but for the most part they're different, distinctly different by one thing. And here it is. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So a parallelogram has two pairs of parallel sides, where a trapezoid has just one. That's what makes it different. So a rectangle, a square, and a rhombus could never be a trapezoid. And a trapezoid could never be a parallelogram, and therefore not a rectangle, a square, or a rhombus. Then there's one special type of trapezoid, and it is an isosceles trapezoid. And what makes an isosceles trapezoid different from a regular trapezoid is that its legs are congruent. And so we're going to look at what part are the legs of the trapezoid in a minute. So the legs of the trapezoid are congruent. Alright, so theorem, and this is associated with the isosceles trapezoid. Theorem 614 says both pairs, and this only happens in an isosceles trapezoid, of base angles of an isosceles trapezoid are congruent. So here's a little picture of the isosceles trapezoid. It might look like this. And trapezoids are considered, they have two bases. The two sides that are parallel are your bases. The two sides that are not parallel, this would be the leg and the leg. So on an isosceles trapezoid, those legs are congruent. And then this is a base, and then this is a base. So we'll call this base of 1 and base of 2. And in an isosceles trapezoid, according to this theorem, the base angles, this would be one set of base angles here. Those are congruent. You can see that both of those are acute. But we have a second set of base, or a second base up here, so this is a second set of base angles. Those are also congruent, and you can see that those are obtuse. Because these lines are parallel, that would be considered a transversal. What do you know about these two angles here? They are supplementary. So in all trapezoids, not just the isosceles trapezoid, but in all trapezoids, find the parallel bases and then follow along that diagonal, that transversal, so to speak, and the angles on those transversals will be supplementary. Now, they don't always have the trapezoid sitting on their bases, by the way, so I'm going to put up here another picture of what a trapezoid could look like. They like to sometimes sit a trapezoid on one of its non-parallel sides. So this could be a trapezoid right there. You can see that these two sides here are parallel. So this would be a base, and this would be a base. I'll call that sub 1 and sub 2. So it doesn't always sit on its base. They like to rotate it to confuse you. But all you need is one set of parallel lines. And then one more theorem associated with the isosceles trapezoid is theorem 615. And this one we'll use a lot. And it says the diagonals of an isosceles trapezoid are congruent. So what is that similar to? What other figure are the diagonals congruent in? I heard it. Say it really loudly.
Rectangle.
The rectangle. So you might want to add here as a side note, because I could ask you a question, what is similar about a rectangle and an isosceles trapezoid? And I don't want to hear they have one pair of parallel sides, because technically that's not true, because the rectangle has two pairs of parallel sides. Do you see what I'm saying? So I wouldn't accept that as a reason why they're similar. But you might want to put in here has in common. With a rectangle. And thereby technically a square, right? But it's more specific to the rectangle. And so that would look like the diagonals would go from here to there. Bless you. And here to there. Do the diagonals appear to bisect each other? No, but they are congruent. Then the next thing we're going to look at are the parts of any trapezoid. This is not specific to the isosceles. This is to all trapezoids. So let's draw it this way. draw right through the center of that line. Make sure it's directly through the center. So on a trapezoid, it'll have two sides, and in this case, it's these two sides that are parallel. And those parallel sides would be known as your bases. Base of 1, base of 2. Your non-parallel sides, these two, are legs don't have to be congruent, they're only congruent in the isosceles trapezoid. And then this line that we drew in the middle is called your median. When you drive on the road, what's that thing in the middle of the road called? A median. That's why they call it a median. Now, a median mathematically, prior to now, has always been associated with a group of data, where you line up the data from smallest to largest and you find the middle number or average the two middle numbers, and wouldn't that be your median? This is different, although it's kind of the same. So there is a formula to finding your median. So your median, and this is what's used often as well, your median is equal to half the sum of these bases. Base of 1 plus base of 2. And you can put here sum of the bases. So that's everything you ever wanted to know about a trapezoid and more. So we're going to use some of this. I gave you two examples and we'll talk about kites. Can I flip that? All right, so example 1, again, we're going to work in the coordinate grid. Find the length of each diagonal to verify that theorem 615 is true for isosceles trapezoid. MATH. How unique of a name. With vertices M 0, 0, A 0, 3, T 4, 4, and H 4, -1. So where are most of those points? What quadrant? Yeah, so if I were you, I'd draw mostly of quadrant 1. And then plot your points. So does it appear to visually look like a trapezoid? Okay. And so the directions say find the length of each diagonal. So we have to find the length of this diagonal from A to H and this diagonal from M to T. Theoretically, what does theorem 615 say? If this is an isosceles trapezoid, what does it say? They both should be what? They're both congruent. So I'm going to find the distance of AH using the distance formula. So there's my template, and I'm going to plug in my ordered pairs. So here's A and here's H. So you can put your X's here, your Y's here. It doesn't matter which ones you put first. It really doesn't matter. So I'm going to put 4 minus 0, and then -1 minus 3. Add your opposite, and we get 4 squared plus -4 squared equals 16 plus 16, which is the square root of 32. So if I were you, I wouldn't simplify that, because I want to be able to compare it to the other one. So then we're going to find the distance from what to what? From M to T. Also using that distance formula. And so here's M and T. So I've got 4 minus 0 and 4 minus 0, which gives me 4 squared and 4 squared, which is 16 plus 16, which is also the square root of 32. Whoops, missing part of that. So is the theorem true or false? Yeah, so my answer would be since, therefore, since the distances of the diagonals are equal, theorem 615 is true. So they might also give you, outside of the coordinate grid system, the length of the diagonals, and you have to know to set them equal to each other. Or they could give you the base angles, and you have to know to set them equal to each other, either one of these. Or they could give you these angles right here, and you have to know that they're supplementary. So here's one type of problem involving the median. So example 2. And this says, given trapezoid, GHIJ with median KL, find the value of X. And just because they draw a trapezoid that may appear to be isosceles, you can't assume that it's isosceles unless they tell you, or you have a way to find out that the diagonals are congruent, or that the legs are congruent. So as I draw this picture, if it appears to look isosceles, you'll just have to not assume that it is, because there's nothing that tells us that. And the median really has nothing to do with that anyway. So a median always goes straight through the middle. Its endpoints are always on the legs of the trapezoid. And let's say that I gave you the following information. GH is 3x minus 1. KL is 10. And JI is 7x plus 1. I want you to write the equation to solve based on the information that we've looked at already. And then stop, just to make sure you have the right equation. So write down what you think the equation is. What do you know about the median? What does it equal? Half the sum of the bases, right? So if my median is 10, right here, it's equal to 1/2 times the sum of those bases. The sum of the bases would be to add them together, right? If I were you, I would get rid of, well, in this case it doesn't matter. I mean, if you simplify it, you've got 10 equals 1/2 times the 3x and the 7x give you 10x. What happens to the 1 and the -1? They cancel. So can I take half of 10x? Can I easily take half of 10x? Yes. What if this were 7x? Could I easily take half of that? No. So if something in the parentheses, and let's say that I added these two together and I got 10x, I don't know, plus 5. If that's the case, I would not distribute a 1/2 into there. If both items in the parentheses, or if everything in the parentheses is not even, I wouldn't distribute the 1/2. I would get rid of the 1/2 by doing what? Yeah, multiply by that reciprocal of 2. Don't deal with taking half of something that 2 doesn't go evenly into. So then I would have 20 equals, those cancel, 10x. Then what would you do to solve? Divide by 10. So I end up with x equaling 2. And that's what they were looking for, 2. But we would have had the same answer if we had taken half of 10, would have gotten 5x, and then you would have divided both sides by 5, you still would have gotten 2. All right, so let's talk about kites. Kites are an interesting thing. There's a lot of things to know about a kite. So your definition of a kite would be that it is a quadrilateral. And again, I want to point out that the kite is not in the same family as the trapezoid or the parallelogram. I mean, they're all quadrilaterals, so they're all part of the overall family of quadrilaterals. They're siblings, right? But trapezoids are not parallelograms, kites are not parallelograms, for the most part. A kite could become one. We'll talk about that in a minute. So a quadrilateral with 2 distinct pairs of adjacent sides that are congruent. Bless you. So a kite would look like this. Let's go fly and send it soaring. So many things with kites. If only we had time and geometry, we'd make kites using your quadrilaterals. Alright, so there's your kite. So when it says 2 distinct pairs of adjacent sides that are congruent, well, it's obviously not these, right? This side and this side are congruent, and these 2 sides here are congruent. Then several things start to occur. Thing 1. The diagonals of a kite are, and I'll let you come to this conclusion, here would be the diagonals. What are the diagonals to each other? They are perpendicular. All right, thing 2. One pair of opposite angles are congruent. Can you tell me which pair it might be? Is it this pair? Nope. How about this pair? Nope. How about this pair? This is it. So we'll call that the angles between the unequal sides. So here's my unequal sides. Here's this angle here. And here's my other set of unequal sides. There's that angle there. So those angles are congruent. And then finally, a third thing, a kite can become a rhombus or a square. When does that happen? When does it become a rhombus or a square? If all four sides are equal, but then technically we probably wouldn't call it a kite. So this is a very iffy one, but there are some segments of the mathematical population that would say a kite can become a rhombus or a square. You're not going to be, there's only one way you're going to be tested on this, and it's in, remember that grid that you had on your pre and post test? I gave you ages long ago. Oops. Remember this grid? If you don't even remember that, we're in trouble. Well, anyway, that's one of the ways you'll be tested on this is through the grid. Other than that, and on your vocab test, you just have to know those three things and you'll be fine. So let's go ahead and finish out your sheet here. So let's summarize what we've learned. So let's look at the trapezoid, just a plain trapezoid. What makes a trapezoid distinctly different than a plain quadrilateral? What makes it a trapezoid? One pair of parallel sides. So characteristic 1, it has exactly, you might want to use those words, exactly one pair of parallel sides. And then the other thing that we learned about all trapezoids is that the median is equal to 1/2 the sum of the bases. And of course you should know what your trapezoid looks like and what all its parts are. Then our isosceles trapezoid, what makes it different than a regular trapezoid? It's what? The legs are congruent. That's what makes it distinctly different. And when the legs become congruent, what happens? What happens? There's two things that actually happen. We need to add another line here. What's one thing? The what? The base angles are congruent. So base angles are congruent, and there are two pairs of base angles. One for each base, a pair for each base. And then what else also happens? We have to add a third thing down here. What about the diagonal? The diagonals are congruent. All right, so then our kite. We'll actually learn 3 things about our kite, right? So it has 2 distinct pairs of adjacent congruent sides. Oh, thank you. How about that? What else did we learn about the kite? Say that again. The angles between the non-congruent sides are congruent. So angles between non-congruent sides are congruent. What else? We have more. I know we ran out of lines, but we have more. What else? What about the diagonals? So diagonals are perpendicular. And then the last thing that you might want to put on here, even though it could be controversial, is that kites can become a rhombus or a square. And then we have and then I did put others here because aren't there other quadrilaterals that are not a parallelogram, a trapezoid, or a kite? Right? So obviously that would be things that don't fall into that category. So then I wanted to give you another visual representation because some of you like that. Here's a Venn diagram. Let's see if I can back it all. Here's a Venn diagram of quadrilaterals. Now in this Venn diagram is not included the kites. Kites would be over here somewhere by themselves, just like the trapezoids are. So within the whole yellow region of quadrilaterals, you contain the family of parallelograms and trapezoids. And of course a kite would be over here, so you could just draw a little kite there if you wanted to. Within the parallelogram family, there are 3 families. The rectangle and the rhombus merge and make that love child, the square. Right? And then the trapezoid, within the trapezoid is the isosceles trapezoid. And then the last thing I'm going to give you, and this is really part of tomorrow's homework, but I'm going to give it to you early in case you want to start studying it, is what I put up here earlier, the grid. And this is an overall summary of quadrilaterals. You can start working on it tonight if you want to. It is part of tomorrow's homework. That way you can come in tomorrow and ask questions. You can see if what you have is correct. So my suggestion would be that you start studying now, if you haven't already, for this test. Somehow, some way that works best for you, you need to make sense of all these little intricacies and differences regarding quadrilaterals. Whether it's to use that game that I gave you, or this chart that I just handed out, or this Venn diagram, or the tree diagram. I'm going to test you on either. You'll have this tree diagram that you have to fill out, so I'll give it to you blank and you have to fill it out, or I'll give you this chart blank and you have to fill it out. Okay? So I'm warning you now that it's one of those 2. So you need to be able to fill it in completely. And that includes, well obviously if I put this on a test, I put in the missing blanks that are missing, right? So obviously on yours it was missing some blanks, but for the test they'd be there so you'd know how many characteristics you need to fill in. So start studying now. Test is Friday.